Hello, everyone. Welcome to episode number 506 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Once again, AI is where it's at in this week's Fish Fry. But not just any AI. Oh no, we're talking about explainable AI with Johanna Pingel from MathWorks. Johanna and I discuss the difference between complexity and explainability, how you will know if explainability is right for your application, and how explainability will impact the future of AI. Also, this week, I examine how AI could predict extreme wildfire danger. But first, let's welcome Johanna to Fish Fry. Hi, Johanna. Thank you so much for joining me.
Happy to be here.
Excellent. Okay, so we're talking about AI today, but specifically explainable AI. So, Johanna, what exactly is explainable AI?
Oh, that's a great question. I'll back up just a little bit and talk a little bit about what led up to explainable AI, and I think that'll give a good introduction into that question. So I started at MathWorks around 8 years ago in image processing. And even then, machine learning, deep learning, AI topics would naturally come up in customer visits. And even then, the concept of explainability would naturally come up too, even if they weren't necessarily calling it that, because engineers and scientists were really interested in machine learning and deep learning techniques, but they were also a little bit wary about machine learning and deep learning and incorporating that into their work. I would get questions like, how does the algorithm work? What is it basing its decision on? And this was in response to maybe showing a neural network or a machine learning algorithm that would take input and learn the appropriate output. So at first, the first few layers of the model, you could understand what it's doing. You could say, oh, this model is learning color and shape and size of the input. But then after you progress more into the more further down layers, you wouldn't be able to necessarily describe what the machine learning or deep learning algorithm was talking about because the output was so abstract. So it wasn't something that you could describe in natural language. It was just, a series of numbers. So from the beginning, it's been a bit confusing in the machine learning and deep learning algorithms to say, this is what the model is learning. This is what the model is doing. And that's where explainable AI comes in. It's really trying to be the solution to the black box nature of AI algorithms. Explainable AI is the broad term to answer the question, what is the model doing? How is it learning? So that when the model doesn't work the way that I want it to, I know what to do and what to change in order to pull meaning from that. Now, the term explainable AI is inherently broad. What does explainable mean? This could mean different things to different people. So it could mean a non-technical explanation. It could mean a technical explanation or something that you would want to give to your manager to understand how the model is making the decisions. And you can trust that the model is going to work as you expect.
So, Johanna, explain to me the difference between complexity and explainability.
Oh, that's a good question. The complexity of models is what we talk about a lot for AI models, just because it's black box and can be very complex, especially when you're talking about neural networks or transformer models or the latest algorithm. But we can take a step back and talk about a very basic model where, let's say, a model of a thermostat, very explainable, very easy to understand. If I set the thermostat to a certain number, it's going to turn the heat on at that number. And then when it reaches that number, it's going to turn it off. So if things aren't working the way you expect for a thermostat, you'll know it right away. You'll feel it, you'll see it, and it will just be something that you can explain to someone to help fix it. But now we move on to more complicated models where there's more predictive power because they can do more things, but there's also more variables and also more things for that model to learn. So as the complexity increases in these models, explainability will naturally decrease. So you could start with a traditional machine learning model, which may be a little bit more explainable. And you should use a more explainable model if you can. But if you need that predictive power, you want to gradually increase that complexity. But then naturally the explainability will also decrease because the model's decisions might not be as straightforward. So to answer the question, complexity and explainability are really the inverse of each other.
I see. Now, what are the current explainability methods out there?
Ooh, how much time do you have? Let's keep it short and simple then. Let's do two different categories because the techniques are coming out, let's say, every day. We can really break this down into categories so that if you see a new technique, it'll probably fall into one of these categories. So the first is visualization techniques. And most visualization techniques are used after a model is trained, and you want an insight into why the model is making a certain decision. So I like the example of an image processing algorithm where you give it an image and it will tell you what that image is. For example, you could have an image of a coffee cup and the model is not getting the answer right. It's not a coffee cup. It's actually saying it's a wristwatch or it's a hand or something like that. And you're saying, well, why a coffee cup doesn't look like a wristwatch? But then you give it an input image. You can use a visualization technique where it will actually pinpoint the location of the image where it's making its decision. So if, for example, you're holding the coffee cup, you might have a wristwatch on your hand, and the model was looking at that instead of the coffee cup. So the visualization techniques are really giving you insight into where the model is looking and could give you insight into how to update the model to make a better prediction. So that's one example. Now, that's a very simple example of a wristwatch and a coffee example. However, you could actually use this in medical imaging as well. And a customer of ours used this to take input images of X-ray images and use visualization techniques to pinpoint where in the image the model is looking for the answer. And so this can really give a practitioner a little bit more insight into where to look in the image and where the model is looking as well. So there really are real world benefits of using visualization techniques. The final thing I'll talk about is interpretability techniques. Now, this is more about machine learning algorithms. And let's use an example of predicting a value of a car based on information or certain features of the car, such as the year, the make, the model. So after the model makes a prediction, you can use techniques maybe like partial dependency plots or Lime or Shapley values. Those are just a few name drops that I'll put in there. And this will indicate the features that were most important to the model. So this could be very important for applications like credit rating and finance industries, where the banks really do want to prove how the model came to a particular conclusion to guarantee fairness in the models as well. So these are just a few of the examples of visualization techniques and interpretability techniques that can really help give you insight into your models.
That makes sense. Now, Johanna, how do you know if explainability is right for your application?
I think engineers should ask themselves if they understand how the model is making a decision. So if they can explain that to, let's say, the end user or to whoever stakeholder they have, then maybe explainability isn't necessary because the model is simple enough as is. The thermostat, for example, you probably don't need to use explainability techniques for that. You can probably just explain that using language. However, if the model becomes more complex and you can't come to a very simple explanation of why a model is doing what you expect it to do, there will be room to incorporate explainable methods into the workflow. So, in my opinion, there's never too much explainability for AI. There probably isn't often enough explainability in AI applications.
I see. Now, what are some of the challenges that come with explainable AI and how can designers overcome them?
One of the most common complaints I hear about explainable methods is it offers insight into why a model's making a decision, but it doesn't actually solve the problem. The next logical question is, okay, so what? Now what do? I know the model isn't doing what I expect. I know that the location of the model isn't proper in my image, for example. So now what do you do? And so that's one of the challenges of explainable AI. It doesn't actually solve your problem. It just lets you know a little bit more of where you should look to help uncover that problem. So, in my opinion, to overcome this, engineers can use explainable techniques frequently and often and try a variety of techniques. And so you do want to use a tool such as MATLAB, that will help you uncover all of the different explainable techniques out there, because one explainable technique isn't going to magically solve your problems. You still have to do the work and incorporate a variety of explainable techniques to help understand what the next step is to increase the accuracy of your model.
What do you think will be explainability's impact on the future of AI?
So I think the future might already be here. So as explainable techniques get more and more advanced, explainability and explainable AI is just going to be required of AI models. Just like right now, you would be expected to show the accuracy of the model, what input data you used, what testing parameters you used to create the model. Why not incorporate explainable AI techniques as part of that verification of the model as well? And so that's what I think the future looks like, is it just becomes a basic part of the process. We won't necessarily be talking about it day in and day out, because it'll just be like a normal day-to-day task of the engineer, just one of the many tasks that engineers do to ensure a safe and accurate model.
That makes sense. All right, Johanna, I think it's time for your off the cuff question. Now, since you haven't been on my show before, you get our standard off the cuff. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, the restaurant is closed, what would you have?
Oh, you did say other side of the world. So I'm going to go to Japan and I'm going to have some very nice sushi. However, I do have a 1-year-old at home, so hopefully this question comes with a babysitter as well, and we'll be good to go.
Of course, of course. It's a dream question. You get a babysitter and free travel all the way.
Sounds perfect.
Excellent. Well, thank you so much for coming on my show, Johanna. This was super cool.
Yeah, I'm very happy to be here. Thank you so much.
Have you ever experienced the dangers of a wildfire? I have, at least on a minor level. A couple years ago, when the area of the Columbia Gorge was crippled with wildfire, the sky around my house was an eerie red color, and the air was so toxic you couldn't be outside at all. One of my best friend's husbands also fought forest fires in northern Washington for years, and the stories he shared with me are not for the faint of heart. But what if technology, specifically AI, could help us predict extreme wildfire danger? So, accurately predicting when and where a wildfire will arise is crucial to the allocation of resources for proper wildfire mitigation. But right now, our forecast models when it comes to wildfires just aren't good enough. They are incapable of providing a long enough lead time to get those resources in place. And this is where AI comes in. You see, a team of researchers from South Korea and the United States have developed a new hybrid wildfire prediction method that combines both weather forecasts and AI techniques that improves predictions of extreme wildfire danger to a finer detail and for a longer amount of time. Lead author of this study, Dr. Rak-Sung Son, a recent PhD from Gwangju Institute of Science and Technology in South Korea, explains the magnitude of this new fire prediction system like this. He says, "We tried numerous approaches to integrate machine learning with traditional weather forecast models to improve forecasts of wildfire risks. This study is a big step forward as it demonstrates the potential of such an effort for enhancing fire danger prediction without the need for extra computing power." So, there are two very important aspects of this study: the AI, of course, and the computational efficiency. So, the AI predictions in this case have been trained specifically on the western United States, including very detailed geographical characteristics, including canyons, mountains, and the strong winds that accompany this area of the world. Other more coarser models for this kind of wildfire prediction found this level of detail rather difficult to resolve. The other important aspect here is that computational efficiency, which is a major advantage for this method. Previous fire prediction methods, especially for these finer resolutions, were very computationally demanding and expensive and time consuming. But this new method is quite different. After its developing stage where the computational resources are similar, and once the training task for the AI has been completed, this system only takes mere seconds to produce a forecast model that can be used for the rest of the season. So, this new AI-based method could not only make accurate, high-resolution forecasts in a shorter amount of time, but also make them in a much more cost-effective manner as well. But researchers have big plans for this technology that go way beyond just the western half of the United States. Co-author of this study, Dr. Philip J. Roche of the Pacific Northwest National Laboratory and the University of Washington, says this about the future of this technology. He says, "In this study, the AI is only tested for fire danger forecasting in the western United States. In the future, it could be applied to other types of weather extremes or to other parts of the world. The flexibility of our AI method can help forecast any weather-related feature." Wow, super cool, right? Or hot, as the case may be. So if you want even more information about this new AI wildfire prediction method, I've included a couple links below the player on this week's fish frying page on eejournal.com and in the YouTube video description as well. If you want even more fish fry interviews about artificial intelligence, I would encourage you to check out my new playlist on YouTube called AI on Amelia's Weekly Fish Fry. In this series, I chat with AI author Peter Scott about ethics in artificial intelligence. I also check out the largest AI processor ever made, neuromorphic computing, and more. And you can check out this playlist by clicking the link below the player on this week's fish frying page, or you can just head on over to youtube.com/eejournal and scroll down a bit, and there it'll be. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal Twitter account, check out AmeliaD1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have that YouTube channel I just mentioned, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's fish frying page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. Also, if you'd like further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's fish frying page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of November 4th, 2022, I'm Amelia Dalton, and you've been fried.